Hello, Lovelace, and welcome to today's science lesson, carrying on our work on materials and their properties. Today, our focus is going to be thermal insulation. So, do I understand what a thermal insulator is? Well, there's a few words in there, a couple of words. Thermal, that's to do with heat. So, when it's really, really cold, maybe you wear your thermals, your thermal underwear. It's all to do with heat. And an insulator, as we say, is something that keeps it in. Okay, so today we need to know what conduct and insulate mean. We need to be able to make predictions using our own existing knowledge. And we need to investigate which materials are efficient thermal insulators. Okay, there's our challenge for today. So first of all, to know what conduct and insulate actually mean. Right. To conduct. To conduct means to allow heat or electricity to travel through the material. And here's an example for you. If you heat one end of a metal bar, the heat is conducted along the metal and you'll burn your hand. So I don't know if anyone's ever done anything similar to this, hopefully accidentally, but if you can see in the picture there, if this end of the metal bar is heated up, heat is conducted, it travels along the material, along the metal, and this end becomes very, very hot and you burn yourself. Okay, so conduct means to travel along, to travel through the material, and it usually relates to heat or electricity. Okay. Now today we're focusing on heat, but electricity can be conducted as well. Okay. So conduct means to travel through or allow these things to travel through the material. Now to insulate is the opposite. It means not allow heat or electricity to travel through the material. So the example here is a coat. If you wear a winter coat, it insulates you by keeping your body heat trapped inside and not letting it out. Okay, so your body is able to produce a certain amount of heat, but in cold weather, that can escape unless we trap it inside. So the materials in the coat do just that. They keep the heat inside. They don't allow it to travel through the material and escape. Okay, so an insulator keeps the heat in. Okay, and as I say, you can have insulators of electricity, but today we're going to focus on heat. Now, our homes are insulated to help keep us warm and save money and energy. We put layers of special insulating material in the roof space, and that traps heat inside the house. Anyone who's been into their attic, into their loft space, may find material like this. The more modern ones is a pinky material, but it does the same job. Okay? And this traps the heat and stops it escaping through the roof of your house. Okay? We also put insulation in the walls of our homes. Okay, so behind the plasterboard, behind the nice painted surfaces, most buildings now will have insulation in the walls. And again, it's there to trap the heat inside. So it doesn't escape and your house stays lovely and warm, but doesn't waste money doing that. Now, here's an interesting image. This photo was taken using what we call a thermal camera. A thermal camera detects heat. Okay? And so here we can see two houses, the one on the left and one on the right. Now, I want you to decide which one is better insulated. Which one do you think has got the most insulation in their house? Right. Well, the house on the left, this one here, is well insulated. And we can tell that because it's showing lots of blue colours. So on the outside of the house, it's quite cold. Heat is not escaping from this house. The heat is trapped inside, keeping the people in there lovely and warm. Okay, so this one is well insulated. However, the house on the right, this one here, is not very well insulated. There's lots of yellows and reds, which means a lot of heat is escaping. So all the energy, all the money they're spending heating their house, they're allowing that heat just to escape through the windows and through the walls and all these areas where it's brightly colored. Okay. So what do you think your house would look like under a thermal camera? Do you think you're well insulated and trapping in all that lovely heat? Or do you think all that heat is escaping through the windows and walls? Now, some materials allow heat to travel through them easily. So those are the conductors. But some materials that don't allow heat to travel through them easily, we call these insulators. Okay. Both of these properties are important, but for different reasons in different objects. So manufacturers need to understand if a material is a good conductor or if it's a good insulator. Okay. Now, I know a lot of you are helping out at home, and some of you are even helping out in the kitchen. So well done, guys. Any help you're giving to mums and dads and other members of your family, I know how much they appreciate it. So well done. So let's think about a pan. For those of you helping out in the kitchen, let's look at a pan as a really good example of these properties. Now, we need the main part of the pan to be a conductor, so that heat from the hob reaches the food. When you put your pan down, either onto the gas burner or onto the electric ring, then you want the heat to travel through the pan and into the food that's inside. Okay, so that needs to be a really good conductor. It needs to let that heat through. So manufacturers often use metals for this part of the pan. There are other materials, but the most common material for that part of the pan will be some sort of metal, okay, because it's a really good conductor. It allows that heat to travel through. But if that heat was allowed to travel from the pan, the main part of the pan, and into the handle, then every time you went cooking, you'd be burning your hands. So that wouldn't be a good idea. Okay? So the material for the handle needs to be an insulator. Okay, we don't want the heat to travel through that. Okay, so the handle needs to be an insulator. And usually manufacturers will use some sort of hard plastic for this. Again, there are different materials out there, but say a strong hard plastic is the most common insulating material for that part of the pan. So you can see the manufacturer had to understand conductors and insulators to create a pan that's safe to use, but cooks our food well. So, what types of materials do make good thermal insulators? So, what materials will keep the heat in? Today, we're going to do an investigation into the materials that kitchen containers are made out of. So, pans, cups, mugs, Tupperwares, all those sorts of things. So, the containers you find in your kitchen. Which material is the best insulator? Now, this is the important message. Pay attention. This is going to be a heat experiment and we're going to be using hot water. It's really important. I cannot stress this enough. It is really important you've got an adult to help you when setting up this piece of work. Okay? You can do the observations, you can do the write-ups, but I want an adult to help you set up this experiment, please. Okay? Hot water can be very dangerous if we don't respect it and treat it properly. So please, guys, an adult to help you with this one. So here's your task. Find a selection of containers that are made of different materials. So for example, maybe a mug, so that's made out of clay. Maybe a glass. Maybe a pan made out of metal. And there's a Tupperware, plastic tub. Okay, so 4 different containers that you just find in your kitchen. All of them are watertight, so all of them will hold water, but they're made of different materials. Okay. Now, carefully, and this is the point where I might suggest you ask your adult to help you to actually do this. But carefully pour some hot water into each container so it's about half full. You don't need to go near the top. We don't want to risk it pouring over the top. So about half full is fine. Now, we've been talking a lot over the last couple of weeks about fair testing. Now, I know all these containers are going to be different sizes. So this isn't a totally fair test, but it does give us some good information. So it's still good science, but no, it's not a totally fair test. And I do understand that. Unless you've got 4 or 5 containers exactly the same size, made of different materials, we can't make it totally fair. Okay, so I do understand that. Okay, so we have very carefully, we've poured hot water into each of the containers, so they're about half full. Predict, make a decision. Which do you think will keep the water the warmest for the longest? Which do you think is the best container to keep the water hot? And now I just want you to wait. Don't touch anything. I want you to wait. Allow the water to start to cool down. After about 10 minutes, so you're giving it a good bit of time to start to cool down. After about 10 minutes, go back and very carefully feel the outside of the containers. Do not put your hands in the water. Feel the outside of the container. Which one do you think has kept the water the hottest? Okay. Now, if you've got a thermometer that you're allowed to use, this will be a good opportunity to use a thermometer, but you don't need to worry. Just touching the container on the side is fine. Okay. But if you have got a thermometer, it will be a more precise way of getting your results. Okay, so carefully touch the side and decide which one is the hottest, which one has kept the water the hottest, which one's next, and which one is the coolest. So which one has let the most heat escape. Then I want you to rank the materials from best to worst. Okay, so the one that stayed the hottest is your best insulator. It's kept the water the hottest for all that time. Okay, so first, second, third, and fourth, or however many containers you've done. Create a clear table of results. So, for example, it could be 3 columns. The first one, the container itself. So in my case, it might be the mug. The material, well, it's made of clay. And maybe it was the second best. And you put all your different containers in your table. And this is what I would like to see on tapestry. So the different containers you've tried, what material they're made of, and then where they came. Were they the first? Were they best? Second best, third, fourth, and so on. Okay, hopefully that is clear. That is the end of the session, but I want to just re-emphasize what I said about safety on this one. Okay, using hot water, you need to be very, very careful to avoid any scalding, any burning. So please, guys, take care with it. Make sure an adult is supervising and supporting you when you're doing this particular experiment. But aside from that, stay safe, look after those people around you. Take care, and I will see you very soon.